induced radioactivity or the artificial radioactivity. One is the natural radioactivity, which was discovered by Henry Becquerel in the uranium, in which the uranium-235 and the elements more than this mass number have the natural decay, and they emit the alpha, beta and the gamma rays. That is the natural radioactivity. But here we will study about the artificial or the induced radioactivity. Now here the nucleus is the stable, which is made radioactive by bombarding or by exposing it to the suitable radiation. So we define this the process in which a stable nucleus is converted into radioactive nucleus by exposing it to suitable radiation. Radiation is called induced or artificial radioactivity. Radioactivity. It means that if the stable nucleus is exposed to any kind of radiation, that cannot make it to the induced radioactive. So this should be exposed to a suitable radiation. The radiation may be like the particles, it may be the alpha particle, it may be the beta particle, it may be the neutron, it may be any other radiation in which the stable nucleus is converted into the radioactive nucleus. So now there are so many examples of this kind of radioactive elements or radioactive nuclei. So let us take some examples. Number 1, aluminum 1327 exposed to helium particle. When this helium particle is bombarded on the aluminum nucleus, then this nucleus converts into the radioactive nuclei. This is now phosphorus 1530 plus N01. This is now radioactive. This nucleus, phosphorus 1530, this further decays into another nuclei, which is the silicon. 30 plus E plus 1, 0. This is the positron. So this phosphorus is converted into the silicon. So this aluminum nucleus was not the radioactive, but it has been made the radioactive by bombarding it with the helium particle, and it converts into this phosphorus nuclei, and this phosphorus nuclei is radioactive. So this further decays and it emits a positron, and here the nucleus is of silicon atom. Now example number 2. Magnesium 1224 plus He24. This converts into silicon 1427 plus a neutron N01. This is now radioactive. This further decays into the aluminum 1327 plus a positron. Similarly, now if we have this uranium 92-238 plus N01, then this converts into uranium 92-239 plus a gamma rays. This is now gamma rays. This is now further goes to convert into neptunium, and that is now your 93-239 plus emission of a electron, and this further converts into the plutonium 94-39 plus a electron. So this you can see that here we have converted this uranium 92-235 into uranium 92-239. This further becomes radioactive and is converted into the neptunium. Neptunium is further converted into the plutonium. So this is a series of conversion. And now number 4 that we can have beryllium 49 plus He24. This converts into carbon 613 plus, this is now your, and this carbon 13 converts into the carbon 612 plus N01. This is the conversion of this one. So when this beryllium is exposed to helium particles, then This is converted into carbon 613. Carbon 613 is radioactive. This further converts into carbon 612 with the emission of neutron. So there are number of reactions in which the stable nucleus is converted into the radioactive nucleus, which is further goes to the radioactive and then it converts into the stable nucleus. Now this induced radioactivity is very useful. Induced radioactivity is very useful to make radioisotopes which are used to cure the cancer. Like cobalt 60. Cobalt 60 is used to cure the cancer. With the help of this induced radioactivity, Rutherford discovered the neutron. Discovered neutron by means of induced radioactivity. Induced radioactivity. Many new elements have been discovered by induced radioactivity. Induced radioactivity. So these are the uses of this induced radioactivity. It means that induced radioactivity is much more useful to cure the cancer by making the radioisotopes and also to discover some new elements, just as the Rutherford discovered the neutron that exists inside the nucleus, and also some new elements have been discovered by means of induced radioactivity. So this is about the induced radioactivity or the artificial radioactivity. So thank you very much.